Alright lads, so we've done a little bit of work there on gear ratios. So what we're moving on to now is worm gears and worm drives. Right, so you've taken a couple of notes already today on it, and this is a worked example that you want to take down in your notes copy. Right, so the question, it asks us, it gives us two sketches, sketch A and sketch B here, and they show two possible mechanisms for an operation of a robot claw. First part says name the gear mechanism shown in sketch A. So this mechanism here is called a worm drive. Okay, sketch B, that is a spur gear. Okay, so a spur gear. Now the name of it is a worm drive here. The fella in the middle, that's our worm, and the two gears on the outside, those are our worm wheels. Okay, so you can label those in your diagram. Number two there, state two advantages of using the mechanism in A over B to operate a robot claw. Okay, so the first advantage really is that the worm wheel or the worm gear, it slows down the speed. So we can see here in the question it says shaft speed is at 72 RPM, so that's rotating at 72 revolutions a minute. If this one here was to rotate at the same speed, this would be opening very, very quickly, and it's not very good as a robot claw. So this one moves very slowly, so it allows for more precise movements. It also creates more torque, which is a turning force, obviously, and it allows the robot claw to hold on to stuff. Okay, so the second advantage then there is that the worm drive can act as a lock and prevents it from moving when the driving shaft has stopped turning. Okay, so when you turn off this robot, these claws will stay in the position they were in, so it can't move. Okay, so that's a second benefit or advantage. Okay, number three there, so this is the one I'm interested in today. Using the information given in sketch A, calculate the time taken for the arm of the claw to move through 60 degrees. So we want to move this from whatever position it's in through 60 degrees out this way or out the other way. Okay, so our information is 72 RPM, our gear has 36 teeth, and we want to go 60 degrees. Okay, so I'm going to switch over now to my page and we'll go through that question. Okay, so I've done a little sketch here and it is 72 RPM, that's pointing at my worm. Okay, and the gear has 36 teeth and we want to move it through 60 degrees, so I'm just going to write that down over there. So this thing goes at 32 RPM, but every time this spins around once, we move one of these teeth. Okay, so what we want to do is we want to move this by 60 degrees. This wheel here is 360 degrees altogether, so we want to find out how many teeth do we need to move in order to get 60 degrees. So we'll make this into a fraction, so we have 60 over 360 degrees, that gives us 6. So 6 is the amount of teeth, the number of teeth that we need to move in order to get 60 degrees. That's fair enough. Okay, so now we know that the shaft moves at 72 RPM in 60 seconds. So 72 revolutions in 60 seconds. Now we don't want 72 revolutions, we want 6. We want this to spin around 6 times so we can move this 6 times. Okay, so we'll make this into a fraction as well. So 6 teeth over 72 revolutions, we'll multiply that by our 60, gives us basic maths now lads. We'll divide that in there. 6 into 6 goes once, 6 into 72 goes 12 times, that gives us 60 over 12, which gives us 5 seconds. So it should take 5 seconds of this worm wheel spinning around to move through 60 degrees. Okay, so that's the worked example for today. Make sure you get that taken down. Thanks very much lads.